All right, so now we're going to look at graphing the tangent and the cotangent function. We're going to do something similar to start with. We're going to kind of use our unit circle, which should be what you see on your screen right now, to plot some points for the tangent function. So remember, our tangent function is y over x. So when we have all these ordered pairs, we can build our tangent function by thinking of the tangent of 0 as y, 0 over 1. So that's going to be 0. The tangent of pi over 6 will be 1/2 over the square root of 3, etc. Now, before we start kind of building our tangent function in Desmos, I want to talk a little bit about what happens, say, at pi over 2, and also down here at 3 pi over 2. So if our tangent function is y over x, and we have the ordered pair 0, 1, then y over x is going to be 1 divided by 0, meaning our tangent function is undefined at pi over 2. Same thing for 3 pi over 2, and then every time we come back around and hit some coterminal angle with pi over 2 or 3 pi over 2, we're going to be undefined. So our tangent function, unlike our cosine and sine function, is going to have places where it's undefined. And those undefined places are going to show up as vertical asymptotes. So let's go ahead and take a look. So I went ahead and built some of our tangent functions in the first quadrant, right? So here, our tangent function is y over x. So at 0, we have 0 over 1, which makes 0. At pi over 6, we've got this mess, 1/2 over the square root of 3. If we do some simplification, 1/2 divided by the square root of 3 is the same thing as 1/2 times 2 over the square root of 3. The 2's cancel, and we're left with 1 over the square root of 3. If I rationalize that, we get the square root of 3 over 3. For pi over 4, we've got square root of 2 divided by 2 over the square root of 2 divided by 2, which is just 1. And then for pi over 3, we'll have square root of 3 over 2 divided by 1/2. Simplification just shows us that that's just square root of 3. And then remember, tangent of pi over 2 is 1 over 0. So those are our values for the tangent function given by the first quadrant of our unit circle. So if we go over to Desmos here and we graph those, 0, 0, pi over 6 square root of 3 over 3, pi over 4, 1, pi over 3 square root, pi over 3 square root of 3. Notice I can't graph the undefined thing because I wouldn't know what to put as an ordered pair. Pi over 2 undefined, that doesn't really make sense. We start to get a picture of our tangent function. Now we could plot a bunch more points to get a better picture, but let's just go ahead and look at what our tangent function looks like. Okay, so here's our points in the first quadrant. Now think about for the second quadrant, our tangent function is going to be negative because we'll have positive y values divided by negative x values. So down here, this is showing our second quadrant tangent values, and then our third quadrant tangent values. In the third quadrant, we've got negative, negative. Negative divided by negative is a positive. And then our fourth quadrant tangent values will be down here because they'll again be negative. Okay, so this is our tangent function. It looks very different from our sine and cosine functions. Our sine and cosine functions were those nice waves. This is not waves, right? These are just kind of repeated S-curves. Now, if we look at this, let's see if we can't figure out what a period is. Well, it sure seems like the period of this is going to encompass kind of one of these. We can even zoom out. Oh my goodness, we've got just a lot of these kind of repeated wavy lines. So one period is going to encompass one of these wavy lines, okay? And so one way to think about a period is our period is going to go between our undefined values. So for example, one undefined value is negative pi over 2. Notice that this creates a vertical asymptote, and x equals pi over 2. So there's one period of our tangent function right there, okay? So that period goes from negative pi over 2 to pi over 2. So that's going to be a total period of pi. Another way to look at that, if I turn these off, let's look at from 0 to pi, because that should also give us one period of our tangent function. Now it looks a little weird, but remember that a period is just one complete cycle of this graph. And that's the positive part and the negative part. So that is one complete cycle. It just looks a little weird. It tends to be more sensical for us to think about the period of our tangent function as being negative pi over 2 to pi over 2, even though that is a total length of pi. Okay, all right. So we know that the period of our tangent function is pi, or going from negative pi over 2 to pi over 2 gives us one full cycle of our tangent function. Unlike our cosine and sine function, this is not going to have amplitude, right? Because these go up forever and down forever. So they're not bounded. They don't go up and then back down, okay? And then our tangent function is just not fully defined everywhere. It's going to be undefined at pi over 2, 3 pi over 2, and then continuing versions of that. So every time we complete that cycle, every pi after pi over 2, we're going to have an undefined part of our tangent function. Or in other words, our tangent function is going to have a vertical asymptote, okay? So when we get to sketching our tangent function, everything that we've looked at for our sines and cosines in terms of shifts, so in terms of moving this tangent function up and down and left and right, and also stretching the period, changing the period, is going to apply. We can also vertically stretch and shrink our tangent function, but it doesn't really matter as much as it did for our sines and cosines because the tangent function just doesn't have amplitude, okay? All right, so this is our graph of the tangent function. I'm gonna pause recording for a minute and let's talk about our graph of the cotangent function. All right, so now we're gonna talk about the cotangent function. So our cotangent function is x over y. So when we're thinking about our unit circle to build the tangent, the cotangent function, we're gonna be doing x divided by y. So notice that here at 0, if I'm doing x divided by y, I'm doing 1 divided by 0, or at 0, our cotangent function is undefined, okay? Otherwise, we're gonna follow kind of the same procedure. To find the cotangent of pi over 6, we'll do x over y, square root of 3 over 2 divided by 1/2. Simplifying that gives us the square root of 3. Cotangent of pi over 4, square root of 2 over 2 divided by square root of 2 over 2 is 1. Cotangent of pi over 3 will be 1/2 divided by the square root of 3 over 2. Simplifying and rationalizing gives us the square root of 3 over 3. And cotangent of pi over 2, well, x divided by y is 0 over 1, which is just 0. So over here, I've plotted those values. Notice that I just left 0 blank because at 0, cotangent is undefined, okay? And so here's the start of our cotangent function. Now let's just again go ahead and use our graphing capabilities to graph the rest of this guy. Okay, now this probably looks pretty familiar, right? This looks really similar to the tangent function in terms that we've got these swooping kind of graphs. They're repeated, 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 okay? They just kind of go the reverse order of our tangent graph, and I'll talk a little bit about that in a minute. First thing, let's try and figure out our period. Well, in this case, it's a lot easier to see that our period is pi units long. If we look at between x equals 0 and x equals pi, we get one kind of these cotangent graph things here. They don't have a nice name like our sine waves and our cosine waves. Maybe we need to come up with one. So this also has a period of pi, okay? And it again just repeats, repeats, repeats. Our cotangent function is undefined at 0, at pi, at 2 pi, at 3 pi. In other words, our cotangent function is undefined at multiples of pi, so we get those vertical asymptotes there, okay? And again, when we think about sketching these using transformations, so think about horizontal shifts, vertical shifts, x-axis reflections, y-axis reflections, vertical stretches and horizontal stretches, everything's going to kind of work the same as what we saw in our cosine and sine function. And we'll talk about that a little bit more in the next video. But let's just go ahead for a minute and put both our cotangent function, which is there in green, and our tangent function up, okay? So again, those look really similar. They make very lovely patterns, but notice that they're very similar in that they have kind of this repeated kind of swooping function, only they're going in opposite directions, and their vertical asymptotes or their undefined values are different. Mm-hmm. All right, that's our introduction to the graphs of cotangent and tangent. In the next video, we're going to talk about how we sketch these things by hand using transformations.